In this example, we're given the image of a triangle with its medians. So let's talk first about some properties of the median. The median is defined to be the segment for which, it attaches the midpoint of the opposite side to the vertex. So that means that these two side lengths are the two side lengths are equal. Same thing here, these side lengths are equal to one another. These sub-side lengths, I should say, right? So it's divided into even portions. And the same with this side. We know another property about the medians. The medians, we proved this using Ceva's theorem. The medians always intersect in a single point. They're concurrent, right? And so Ceva's theorem tells us that this point G, right, lies on all three of the medians. And in this section of our study, we have learned another property now. And this last property is that the median, this point G, which we get from Ceva's theorem, divides our median in such a way that the shorter side, so the shorter portion of the median, the portion that's closer to the side, is half the length of the longer portion. So the portion that's closer to the vertex is twice as long as the portion on the side of the adjacent side. And so in some sense you can say that this then divides our medians into thirds, right, where 1/3 is represented by the short one and 2/3 by the long one. Now let's use this information to try to answer this question. So our first two pieces of information are AG and GE, right? So GE is the smaller one, and that means that AG is twice GE. If we just look here how it's divided up, AG is twice GE, and so this equation can then be written as 2x plus 2y is equal to 2 times 2x minus y. And we can rearrange everything here, right, and say that this equation now says that 2x plus 2y is equal to 4x minus 2y. Okay, and if we rearrange a little bit more, right, this can be brought over, this can be brought over, we'll get that 4y must be equal to 2x. Just by doing a little algebra. We still don't know exactly what x and y are. On the next one, we see this information is given about BF, or BG and GF, and same deal here, right? So BG has to be twice GF. That's just by properties of the median and this point here in the middle. And if we write this out, BG is 3y plus 1. GF is x, so this is 2 times x. And so we have 3y plus 1 is equal to 2x. And now we need to solve for x and y, right? We need to find both of them to be able to answer our question. And notice that the way I have it now, both of these two equations are solved for 2x. So let's leave it that way. And by transitivity here, right, what do we learn? That 4y from the left-hand equation must be equal to 3y plus 1. A little subtraction gives us that y must be equal to 1. And now either one of these is going to give us that x is going to be equal to 2, right? Because now we plug that in. So 4y is equal to 2x. So this then goes here. So 4 is equal to 2x. And of course, x must be 2 then. All right, so that's the hardest part of this work. Arranging this, getting the equations, and then doing the algebra. And now our job, though, is to find BF and AE. These are just the sums of the side lengths, right? So now we should just write down exactly, we've got these equations, we should write down exactly what these are. So AG is 2x plus 2y. So AG is equal to 2x plus 2y. That's going to be 2 times 1 plus 2 times 2. So 2 times 2 plus 2 times 1. This is 4 plus 2, so this is 6. And then we can just guess, we can just use ratios to find GE, but let's use the formula. So GE is 2x minus y. All right, and so 2x, this is going to be 2 times 2 minus 1, or 4 minus 1, so that's 3. And of course, it's supposed to be half of that anyway, right? So this checks out. And what we learn then is that AE, the length of AE, is the sum of these two, right? So it's AG plus GE, that's equal to 9. And we can do the same thing with the segment BF. So BG is 3y plus 1. And 3y plus 1 is 3 times 1 plus 1. So that is 4. And GF was just x, right? And we know x is 2. And so again, it works out. And this time we get that BF is equal to 4 plus 2, that's 6. And so there we go. There's an example using medians of triangles.